diversity of technique, for unity of construction. Eduardo Torroja Institute for Construction Science, a body of the Spanish Council for Scientific Research. Here at the Eduardo Torroja Institute, we work to contribute to construction progress, driving innovation in construction systems and techniques, analyzing the reliability of structures and new materials, conducting research to build more comfortable facilities while saving energy, exploring material durability, evaluating the causes of pathological processes, developing new materials, and studying the possibilities of recycling demolition waste to reduce environmental impact. In 1934, a group of engineers under the leadership of José María Aguirre, Modesto López Otero, and Eduardo Torroja created what they named the Technical Institute for Construction and Building, the first organization in Spain to engage exclusively in construction research and improvement. It also aimed to heighten public awareness of progress made in the field of construction science. In 1946, it acceded to the Juan de la Cierva Foundation. 3 years later, it merged with the Cement Institute to form the Construction and Cement Institute. Its present facility at Costillares, Chamartín de la Rosa, today a district of Madrid, was built in 1952 under the supervision of Eduardo Torroja, who inspired its modern and functional style. After Professor Torroja's death in 1961, the center was renamed the Eduardo Torroja Institute for Construction and Cement. Sometime later, it adopted its present denomination, the Eduardo Torroja Institute for Construction Science, maintaining the spirit with which it was created even after its founder's death and through to the present. The Eduardo Torroja Institute for Construction Science, a body of the Spanish Council for Scientific Research, is a center specializing in research and technical support for the construction industry. In the area of building construction, we focus on system performance and innovation. We study improvements in systems and processes for facades and roofs, and seek new solutions with traditional techniques and materials, as well as precast elements that facilitate process industrialization. We also develop new ceramic materials and finishes, with materials ranging from designer porcelainic tile to recovered waste. We counsel the industry on the formulation of technical standards and sit on a number of national and international standardization committees. We also cooperate with central governmental authorities for the development and follow-through of the Technical Building Code. In the area of habitability, we address issues relating to comfort and convenience, energy savings, and health and safety in buildings. We seek optimum building solutions for thermal insulation by subjecting materials to temperature trials. We study and conduct tests on water supply and drainage systems for buildings. We develop construction solutions for sound absorption by analyzing insulation for performance against airborne and impact noise. We design innovative heating and cooling systems as well as modular chimneys for smoke extraction. We draft wastewater drainage pipe performance reports for periods of up to 100 years. The mechanical strength of structures and their members is analyzed by our experts in structural engineering. We use new composite materials in building and civil engineering. We analyze the causes of pathological disorders in all kinds of structures and monitor the behavior of existing construction to guarantee safety. We measure stress absorption and transmission in structures testing them for ultimate limit strength with fatigue and repetitive loading tests to optimize performance. The use of traditional and new concrete in infrastructure, public works and buildings is possible thanks to our studies. The Institute is well equipped with IT tools to support its research and technical activities, including the latest structural and numerical engineering, database and graphics processing software. We study deterioration in modern and historic construction materials. We explore chloride penetration mechanisms and reinforcement carbonation and corrosion to predict durability and reliability. We analyze concrete viability as a material for storing radioactive waste, checking its capacity to confine hazardous substances. We study the processes contributing to concrete deterioration and possible hazardous emissions from construction materials into the air or water. We publish manuals and recommendations for evaluating and repairing deteriorated structures. We participate in the rehabilitation of heritage monuments, sculptures, mural paintings, archaeological deposits, and historic city quarters, designing concrete and mortar for repairs, and studying the cement used in centuries past. In addition to conducting research on ways to save energy in Portland cement manufacture, we analyze the problems relating to concrete deterioration, such as thaumasite attack, exposure to weathering agents, or the formation of salts. We offer an alternative to traditional cement based on the alkali activation of blast furnace slag and the alkali activation or hydrothermal treatment of fly ash. Such alternatives contribute to the country's ability to comply with the Kyoto Protocol while improving certain properties of traditional cement. We ensure that cement quality is not adversely impacted by the waste recycled from other industries for use in concrete. At the Eduardo Torroja Institute, we evaluate innovative techniques and systems that help to dispel architects' and engineers' reservations about using non-standardized products and processes. To this end, we publicize and further the use of the national and European systems of technical approvals based on EDUARDO and EOTA guidelines. We conduct identification, aptness for use, and durability tests on construction products and systems. This includes reviews of the respective engineering and worksite procedures, verification of quality controls in factories, and post-construction inspections to guarantee workmanship. Moreover, the Institute's approval seal for precast joists and slabs is the only quality seal for floor and ceiling slabs that has attained official governmental recognition to date. Our standard sand, the only material of its kind approved by the Spanish Standardization Association, consistently obtains yearly renewal of the association's mark of quality. The Eduardo Torroja Institute is a member of numerous international associations. It represents Spain to EOTA and is one of the founders of the IETcc. At the national level, it partners with many Spanish associations working in the area, drafting and publishing papers and research reports. And its facilities are home to a number of different industry associations. As a public body forming a part of the Spanish Council of Scientific Research, the Eduardo Torroja Institute seeks to transfer the knowledge it generates to society at large, but especially to the construction industry. It publishes 2 periodicals, Informes de la Construcción and Materiales de Construcción. It also produces books and monographs on specific subjects. It organizes encounters and workshops on a routine basis, as well as its prestigious Torroja seminars and specialized courses on new construction techniques and materials geared to professionals. Members of the Institute deliver countless doctoral and postgraduate courses and submit papers and communications to congresses and technical workshops, which they often attend as keynote speakers. While the Eduardo Torroja Institute will certainly change in the years to come, as new names and faces are enlisted in its endeavor, it will remain loyal to its founding spirit and objectives, helping to conserve, improve, and develop one of society's mainstays: construction.